All right, we're back for part 3 of desert terrain. And we're talking about mesa and buttes. And if you know Spanish, then you're thinking, why are we talking about tables, right? That's a good question. So a mesa is just that. It's a flat top, almost like a table. It's a feature that is flat topped and it is wider than tall. Where a butte is flat topped, but it's taller than it's wide. And a chimney, well, let me just show you. Here you have an area, flat area, and maybe it's uplifted, and now there's erosion. So streams carve through, and this is a mesa, so it's wider than it's tall, right? That's a mesa right there. Now, over time, if these get narrower, now you have buttes, and now a butte is taller than it's wide. So a mesa eventually wears down into a butte, and if it keeps on wearing away, it becomes a chimney. So they kind of look like this. Here's a mesa off in the distance right here, right? So this area of the desert southwest, like your video making North America, what was lifted up over time, and then erosion wore it back down, and now you have a layer of hard rock here, softer rock here, and you can see it's flat, but it's wider than it's tall. But over time, this one wore away, and now you have a butte, two buttes right here, right? So this is taller than it's wide, and it keeps on wearing away, and now you have a chimney, right? And all the rocks that wore away, by the way, just kind of accumulate here like a screen around it. They call it a talus apron. That's all the rocks that have fallen off. Okay. Now hogbacks and cuestas are basically the same thing, but the difference here, let me go back, right? In a mesa, usually you have straight sides. The other side's pretty much straight or horizontal. But if that isn't the case, so you have a hogback or cuesta. So a cuesta is where the ground surface, instead of being flat, is angled slightly. So let me go back to that picture. If this was at an angle, a slight angle this way, then it'd be a cuesta. Okay? And a hogback, well, let me just show you. So here's a cuesta, right? It's got the flat top, but the flat top is slightly angled. And so basically if it's less than 30, but if it's more than 30, then you have a hogback. So here actually is basically through faulting of the rock, mesa has been tipped right over. I know that the movie I had you watch about Making North America, one of the last scenes, this really beautiful area in Denver, the Red Rocks Golf Course, you're actually in a hogback formation. And the last thing we'll talk about, these island mountains. So sometimes we come across these features. It's a flat plain, hundreds of miles across, and right in the middle, out of nowhere, this big rocky mountain, big huge rock just sticks up. It's called an Inselberg. And what it is it is another feature that is exposed to exhumation. Remember we talked about ridges and sills and plutons, those things that form underground? Well, what happens is an Inselberg is something that formed underground, a large mass of rock that over time the surrounding soil wore it away. So it looks kind of like this. You have a bunch of rocks here, different layers. They're folded, they're kind of faulted. Maybe it got compressed into this. But some of these wear away, so over time it wears down to this. See, and there's that wearing. Then in the meantime, as these wear down, the little gaps between them get filled in with dirt and soil. And so what looks to us like a little rock sticking out here is actually part of this big, huge feature that we only see the tip of. So here's Uluru. This was known for many years in Australia. It's a sacred site to Aborigines. And it is huge. I think it's about 200 feet from the top to the bottom, if I remember correctly. So in the middle of this flat plain just sticks up. And its sister rock over here, Kata Tujua, it's the same formation. They're hundreds of miles apart. But that's what it looks like to us. A Bornhart is just an Inselberg that looks more rugged because the rock that is created is a stronger rock, right? So what happens is you get this. Here you have this igneous rock, the surface wears away, and you get this. It just looks a little bit more rougher. Here's kind of what it looks like. Now, Last thing we'll talk about, and then we're done, is the Badlands. And I love to end this because it kind of talks about the human aspect of geography. So a Badlands topography is this landscape that's dry, and the rock, it's kind of this, it's not quite rock, but it's not quite dirt. It's almost like thick clay. So if you go to farm it, it's not really good for farming. But if you try to dig through it, it turns into dust. And so because of that, it's a dry area. Any kind of water basically makes these immediate canlands, little gullies and rills. So the slopes are unvegetated. It's clay. You really can't do much in the way of farming. It's very difficult to cross these areas because there's no flat aspects of it. So it's hard to get around. So of course, for people of white settlers coming into these areas, they called them bad lands. They were bad lands. You couldn't farm it, you couldn't mine it, you had to go around it. It was a pain in the butt. So to them, it was worthless. It was called Badlands. I find it interesting that these were also in the United States. We have an area called the Badlands in the Dakotas, which is where Mount Rushmore is. That the Native Americans, the Lakota Indians, considered their sacred homeland, and that wasn't bad to them at all. In fact, so much so that in the 1860s they had signed a treaty with the United States, and the United States said, "You can have this Badlands. We don't want it." And the Native Americans were fine with that. 10 years later, there was a thought there might be gold in the Badlands, and so the United States canceled the treaty and took it back. And the Native Americans said, "Wait a minute, we had a treaty." They actually took them to court. They sued the U.S. government in the 1800s. It took almost 100 years for the courts to finally hear the case. And when they did, the courts agreed that yes, we should give that land back. But by this time, there are cities and towns, and the thought of it giving back would be very tough. So the government had offered to pay them basically billions of dollars to forget this. And the tribe lives currently in a state of poverty. It's one of the most impoverished parts of our country are the Lakota Indian reservations. And to a person, they have decided not to take the money. That land is that sacred to them. The lands that we call bad lands are just sacred to them. Also, if you are a fan of dinosaurs, a lot of fossils are found there. So the dinosaur skeleton Sue at the Field Museum, the Tyrannosaurus Rex, she was found in the Badlands. This is a Badlands formation in China. So it has these really beautiful colors and different minerals, and you can see very rugged, very hilly. And again, I just love the term Badlands. I guess it depends on who you ask. So, let's get back to the human aspect. Desert lakes. So some of the largest lakes in the world are found in deserts. They're often salty, but the reason they're so large is that they're in the interior of a continent, so rivers that don't make it to the ocean make it here. A good example is the Great Salt Lake in Utah, which is one of the largest lakes in the country. Okay, but a lot of these lakes are shrinking because people are using the water in the rivers that go to these lakes and not replenishing them. So we're going to talk about a couple. The Aral Sea in Asia was once the fourth largest body of water in the world. So after the oceans, after the Caspian Sea, it was about as large as all the Great Lakes combined. In the 1960s, government authorities decided to use some of that river water that was flowing into this Salt Lake and use it to irrigate crops, specifically cotton, because the area around it was really good for growing cotton if only they had the water, and cotton makes a really nice profit. But what happens is, if that water from the rivers is being used to grow crops, it's not going into the water. The Aral Sea began to shrink. So that is where it is in Asia, and this is about how big it is. So this is Uzbekistan, Turkmenistan, very large. You see the two main rivers, and they would actually dig canals out of the river to bring the water here to irrigate cotton. But here's the problem. The white outline is the Aral Sea in the 1960s. As you can see today, it's less than 10% of what it once was. It is a vanished sea. It dried up. These are fishing boats. And when the water receded, they just let them sit in the middle of the desert. Now there's camels walking by them. So what are the consequences? Well, one, you can't go fishing there. There's no water to fish. The water that's left is too salty for even fish to live. There were people that had been fishermen for thousands of years, generations of families, and that's gone. Very, very profitable industry, it's gone. Secondly, all the pollution that was in those streams was brought into the Aral Sea and sank to the bottom and got stuck in the seabed. It wasn't a big deal when it was the bottom of the Aral Sea, but now that it's dry, That's dust. That's sand. It's laced with carcinogens, cancer-causing chemicals. Whenever the wind blows, those winds blow all this basically poisonous dust around. And we have seen lung disease, lung cancer, asthma go up dramatically. And the last thing, the climate's gotten worse. So remember we talked about how Lake Michigan makes Chicago warmer in the winter and cooler in the summer? Excuse me. The Aral Sea kind of moderated the climate in the middle of the desert. It made it a little bit cooler during the summer. It made it a little bit warmer in the winter. So it didn't have these extremes. But now that it's dry, it heats up very hot in the summer. It's even hotter in the summer and colder in the winter now. That's not just confined to Asia. The same thing happened here in North America. In the 1900s, as the city of Los Angeles grew, they needed more and more drinking water. They get a lot of their water from the Colorado River, but that wasn't going to be enough, so they actually dug a canal up through Northern California to all these small lakes. And one of the things they did was they sent out people before the canal was built to buy land around these lakes. That way, the people who lived there couldn't stop them. And by 1926, Owens Lake was dry. The city of Los Angeles basically drank all the water out of it. Now, it's interesting. That was one of the biggest lakes in California. It is now, by you measure the air, it is dustier than anywhere else. And dust in that area is 30% more toxic than any other dust in the country. So here is what happens. So here is where the lake used to be. They dig this big, huge canal. It's gone. That's what it was. That's what it is now. And the last part was there was another lake on the canal, the Mono Lake. So Mono Lake was saved. There's some background information. It's unique because we think it may be the oldest lake in North America, 1.5, maybe 2 million years old. By comparison, Lake Michigan is probably 25,000 years old, so much older. Okay. Now LA did the same thing. They bought all the land around the lake. They started draining it, and the level began to drop. By the 1970s, though, people were noticing this and saying, "Wait a minute, we should stop this. This is an important lake. It's old. It has a lot to study." And so, college students your age at a local community college studying environmental studies or physical geography or something similar started a campaign, Save Mono Lake, and they made buttons and they went and they did protest and they got their voices heard. So that by 1994, eventually, they passed a law in California reducing how much water was taken out. And so the lake levels are now stopped. They're not dropping anymore. They're not back to what they have been. They are rising, but they're still much lower. So you can see right here that in 1941, they started taking water out. And you can see from the 1940s all the way through it drop, 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 drop. So now it's going back up. So it's getting better. Still has a ways to go. Here it is right now. You can actually see the old shoreline. Here's that thin white where it's dropped. So that's the difference right there. So the reason I end with this is that these environmental consequences often aren't seen, and they take place to benefit one group, right? So Los Angeles City was benefiting by this, and by no means should they not have water, but that doesn't mean that there were consequences to it, and that how do you change these things? How do you make an effect in this world? I love the fact that this initiative was started by college students. It was college students who went out, they discovered this problem, they did the research, and they started talking about it and working together. And their voices, it maybe took 25, 30 years, but it did work, and the lake has been saved. So this may be a little bit preachy, but this is one of the reasons why I hope you take this class, is that maybe these are the kind of things that will stick with you. But if not, always remember, wash your hands, be safe, and we will talk to you later.